So in this video, we are applying the symmetry we spoke about in the previous video and this idea of reflecting about the x and y axes to define what we call odd and even functions. Now, these have a certain set of characteristics. Now, starting with even functions, these have line symmetry in the y-axis. So what that means is that if we were to reflect this function about the y-axis, we would get the exact same function. It would be unchanged. Now, these algebraically have equations that are unchanged when x is replaced by negative x, and we'll see how this works later. And extending on this means that algebraically, we can define even functions as those where f of x equals to f of negative x. So if we basically substitute in a negative in front of every x that we see, the output will be the same as the original function. That's basically an algebraic sort of summary of the second dot point. Now, odd functions, algebraically, they're odd when f of negative x is equal to negative f of x for all x in the domain. So what this means, in a kind of simplified way, is that whether we reflect this about the y-axis or the x-axis, we will get the same function. So it will look the same. And we will basically show this visually later. But summarizing that, the reflection of the function about the y-axis will be the same as a reflection of the function about the x-axis. Now, most functions that we would have seen are going to be neither even nor odd, but some of them will have these characteristics and we can test these algebraically. Now, in this example, we are going to decide whether the following are odd, even, or neither, and we're going to sketch these as well just to give you a visual that kind of summarizes these dot points that we've spoken about before. Now, if you look at this first function, we have f of x equals to x to the power of 4 minus 3. Now, we're going to test using these two algebraic relationships to decide whether they are odd, even, or neither. Now, let's try the even one first for this. So let's just substitute in negative x for everywhere we see x. Now, this will give us negative x to the power of 4 minus 3. Now, if we raise negative x to the power of 4, because this is an even number, this will give us a positive thing out. Think about it. This is like doing minus x times minus x times minus x times minus x. You're going to get two sets of double negatives. So you will get a positive out. And we notice this guy here is exactly the same as the one up here. So we can say f of negative x equals to f of x. Therefore, the function is even. Okay, so every time we make a test, we are going to draw kind of a conclusion by looking at this algebraically and testing it. It's either going to be this one, the one for odd, or if it doesn't satisfy either of them, it'll fall under this category of neither. Now, just to give this a rough sketch, this family of functions is a quartic, which we've looked at previously in other videos. And this is being shifted down 3 units. So our y-intercept is going to be here. And we get something with a general shape that looks like this. That picture's not great, but we're just giving a general sketch of this function. This is our quartic of f of x equals to x to the power of 4 minus 3. This has intercepts at the 4th root of 3 and the negative 4th root of 3. Don't worry so much about how I've drawn this. You can show this with a table of values or you can revise some of the previous content. But just to show you, you can see with this one, obviously I haven't drawn it very well, but this should look the same on one end as the other. So if you were to reflect this using this as your mirror line, the y-axis, you will get the exact same function. So if this got flipped to this side and everything got shifted over and reflected around here, you would get the same function back. Obviously, if you do a nicer drawing than the one I did, you'll be able to see this a bit more clearly. Moving on to the next one, we have f of x equals to x cubed. So let's just have a look. Let's start off with our f of negative x. We'll test first if it's even. Now this will give us negative x to the power of 3. And we can see because this is an odd number, then I have minus x times minus x times minus x. So I will get a double negative happening with the first two x's that are multiplying, but I have a negative that's multiplying to that. So I'm going to get a negative out. So this is definitely not going to be an even function. You can see a negative sign in front. So f of negative x is not the same as f of x, but we can see that this negative in front, if I were to write negative f of x, this would be x cubed with a negative in front of it. So we can say that f of negative x equals to negative f of x. Now this relationship here that we've established, if you remember back to the previous page, is an odd function. Odd functions have this property here. So we can say, therefore, the function is odd. Now, if we do a rough sketch of this function, we've talked about this one before. This is a cubic, so it has a general shape. Let's do this a bit nicer this time. Looks something like this. Remember, I'm just doing a rough sketch of this. But if we were to rotate this about the y-axis, so this one over here, you would get something that looks kind of like this. So we're rotating about the y-axis, so this point is going to go over here, and every point is going to get mapped to this quadrant opposite it. So my function here, when it's reflected about the y-axis, it looks like this. Now, let's say we did this about the x-axis. So say we reflected it. Well, this point up here would go down to here. This point here would go down to here. That would be the same. And everything would get reflected in the same way. Let's actually do a different color here. But reflecting this about the x-axis, we'd start down here and we would actually get the exact same function, whether we reflect it about the y or the x-axis. So we can say this one is going to be an odd function. Finally, let's look at this one over here. We're going to test. So first of all, we'll test if it's an even function. So we'll say negative x squared minus 2 times negative x. This is going to give us x squared, positive x squared, plus 2x. So we can see that this won't be an even function because while these two bits are the same, the sign has changed from negative to a positive. And if we test negative f of x, that's going to give us negative x squared minus 2x, which when we expand this out, we'll get negative x squared plus 2x. So this one is not the same, well, these two, I should say, are not the same. So it's not an odd function either. So it's not an even function from this first thing we tested. It's not an odd function because these two are not the same. If it's neither odd nor even, we say the function is neither odd nor even. And we can kind of show this visually as well if we were to graph this. Now, if you have the function x squared minus 2x, this is going to, if we factorize it out, be x outside of x minus 2. Now, these are our intercepts. So we have an x-intercept at 0. We have an x-intercept at 2. And if we were to sketch this out, let's actually just change the scale on this. I'll just make 2 over here. Now, this will be a concave up parabola. So just roughly giving a sketch to this, it's going to look something like this. Now, if we were to reflect this about the y-axis, it would look something like this. We'd still have this same intercept here, but it would get reflected. So it would look something like this. So we can pretty clearly see that even symmetry we're talking about, this thing is definitely not the same as this thing. And if we reflected it about the y-axis, about the x-axis, then we would get something that looks kind of like this. Which, unlike up here, where our green graph and our red graph sat perfectly one on top of the other, we can see that that is not the case in this example. We have a pretty clearly two distinct graphs. They are not the same, so the function will not be odd. But hopefully this gives you a better understanding of algebraically how we can show that functions are odd or even or neither, as well as graphically. That brings us to the end of the video. Thank you so much for watching, and I'll see you next time.